The next step is going to be turning the outside of the shaft. We're going to need the support of the live center now in the tailstock. So I'm going to put that back in. Once again, make sure your tapers are clean and there's no dirt on there. Going to move the carriage out of the way. And for safety reasons, since this tool is sharp, let's remove that tool. We'll put it off to the side for right now. I now have to open up the jaws on the chuck. Pull out your workpiece and hang on to about the diameter of it now. And then you tighten the jaws. Now since our hands are moved away from there, we can put the cutting tool back on the tool holder. We can bring the tool bit close to the end of the shaft, and we actually have to change the angle of the tool again. So you need to loosen your tool post. And now this time you want to turn it so that there's clearance while turning the OD. So I actually got to back it away and turn the tool so only the tip is touching. So about there. So what that does is make sure that the nose of the tool is the only thing contacting the shaft. We don't want the back side of the tool to be touching the shaft, just the tip. So then you want to position your tool near the end of the shaft, that way you know where your carriage is going to be. And then bring your tailstock up close to the carriage. Leave yourself about 1/4 inch of room. Clamp the tailstock. And bring your tailstock support up to the shaft. And after you have it tight, you want to lock this handle. So now we're changing to a different process. We went from drilling back to turning now. So we're using our high-speed steel tool bit on mild steel, 1 3/4 inch diameter. So the RPM was 170. So we're going to set the machine back to 170 in low and X. So now for turning, right now this handle is up to control the X hand wheel. We have to put this handle down, and that'll control the Z hand wheel. So I'm going to start the machine and let's just try it and see which direction it's feeding. We don't want it to feed towards the tailstock, we want it to feed that way. So this handle is down. If I engage the feed handle, this one should move counterclockwise. That would take it towards the chuck. So let's just try it. Make sure everything is a safe distance away and just try it. Yep, that looks good. So it's feeding the right direction. If it was feeding the wrong direction, you would have to switch to this lever. This is the feed reversing lever. That's a neutral position, and that's going the other direction. That would feed the carriage to the right. This feeds the carriage to the left. And if you watch this shaft down here, when I run the spindle forward, this shaft rotates the same direction as the spindle. If I switch this handle, that changes the direction of that shaft. So when that shaft changes direction, it changes the direction on the carriage. So it's always important to check that if you don't know which way it's going to feed. So we're going to feed to the left. Now if you remember, there was 2 different charts. One feed chart was for facing, the other one is for turning. So now we want to go again to 1/3 of the nose radius. The tool nose radius is 15 thousandths on this tool, so we want to feed 1/3 of that. So 0.005 on turning. So you need to be CT ME2. CT ME2. That will give you 5 thousandths of travel for every revolution of the spindle. So now we're going to approach the part on the X-axis. We're going to feed over on Z just a little bit so we're on the material. Then we're going to approach on the X-axis. So you'll just see it touch the part. And as soon as it touches the part, you want to feed away on the Z-axis. Just manually by hand move it away. So now at this point we're touching the shaft. The shaft is 1 3/4 inch diameter. So on the digital display now, we can set the x-axis. This will get us close. We know it's rough material, but let's set it anyhow. If we push the X key, we can enter in the size that it is at. So that says we're at 1.750, which is 1 3/4 inch. So let's set the Z-axis now. So I want to make sure I'm away from the end of the part. I'm going to feed in on X. I'm going to start the machine and just barely touch the end of the part. Just as soon as it touches, I'm going to stop moving. I'm going to back away on X. And now on Z, I can set Z to be 0. Now once again, that's just the starting point. We should cut and then measure. So we're ready to start taking our first turning cut. So we're going to feed away from the machine, or away from the material on Z. We're going to move in on X, and remember it touched at 1.75. So a good rough cut for a high-speed steel tool bit is probably 50 thousandths. That would give you a 25 thousandths depth of cut. So I'm going to start the machine. And as soon as I engage the feed, it's going to feed towards the chuck. And just apply a little bit of coolant again, just a little bit. So if you notice, my chips are a little bit long, but they're breaking themselves off. You don't want to be anywhere near those chips. They're very sharp, and those chips right now, as they come off the material, they're actually spinning. I don't have a blueprint in front of me, but if you wanted to follow a blueprint, that's the best idea. I'm just going to pretend that I'm making this cut a 1 inch long cut. So on my readout now, I'm going to be watching the numbers. And as the numbers count towards negative 1.0, I'm going to stop. I'll probably stop at negative 0.95. That way there, it gives me a chance to actually measure where I'm at. So 0.95 is where I'm stopping for right now. That's 50 thousandths away from 1 inch. And I'm going to feed away from the material on the X handle. And turn off the machine. Now since I've taken a cut with the tool bit, I want to measure what size it's actually cutting. I know on the display I set it to 1.7, but that was just off of touching the outside of the tool. So now this is where you take a micrometer and measure that diameter. So with the micrometer, make sure your surface is clean. We know it's about 1.7, so I can open up the micrometer at least that far. Put it on the material, and I'll close it using the ratchet stop. So I'm going to move the micrometer around a little bit to find the high point, and the ratchet applies just enough torque to there to be accurate. I can't read it where it's at right now, so I'm going to lock it, slide it off, and then read the size. And it actually is 1 inch, 0.7, right on the head. So this verifies that my display is accurate. So you would do the same thing for the length. You want to double check to make sure your length is right. We turned it from the end to that shoulder at 950 thousandths. The most accurate way to do that would be remove your tailstock and go get a depth micrometer. Put the micrometer on there and measure to that shoulder. I'm just going to pretend I measured it. Let's say it measures 950 thousandths exactly again. So I don't have to make any adjustment on that. Where I touched 0 was right on. If you ever measure it and you find out your display is inaccurate, at that time change your display, take another cut, and make sure that the display is accurate. So let's hit the target size of I was at 1.7, so let's go down to 1.680. When you're using a hand-grown tool bit, you can take a light finish cut. So I want to take it on the x-axis. We were at 1.7. Let's go to 1.690. We'll make that our first finished cut. That will give me another cut of the same size to get down to 1.680, which is my target size. For finished cuts, since there's not as much heat involved, you can use a little bit of oil. Now this is only for high-speed steel tools. If you're using a carbide tool, you wouldn't want to use oil. That would make all kinds of smoke. Engage your feed handle, and as it feeds towards the chuck, you'll see a small shaving coming off. Now this shaving is going to be a lot smaller than the last cut. So I have my digital display set at 1.690. After this cut, I'm going to measure it again to make sure it's still reading the value of that display. I'm at 0.950 and I'm going to hand feed the 0.975. So this was my first finished pass. This now gives me the opportunity of measuring the diameter again and measuring the length to make sure that my display is accurate. So first, make sure your diameter is clean. We'll take the micrometer again. And we'll measure the diameter. And we were supposed to be at 1.690, and it says I'm at 1.691. So what that means is that my machine is cutting a thousandths bigger than my display said. So when this was at 1.690, it actually cut 1.691. So you could make that adjustment now. Depending on the tolerance of your print, generally, if you're within a thousandths, that's going to be close enough for this first project. So I'm going to leave that alone. So we're going to start the machine and take our last cut. Apply a little bit of oil. We're going to take the x-axis to 1.680. That's my finished size. Engage your feed handle, and this will take another light finish cut. This time I'll stop the power feed at 0.975. Now I'm going to hand feed to 1 inch exactly. Feed away on your x-axis. Turn off your machine. Move away on the z-axis. Now at this time you can perform your final inspection. Make sure that your diameter and your length are exactly what you want. It measures 1.680. If you use the depth micrometer to measure the length, it should measure 1 inch on the length. So this is how you turn a diameter on a lathe, taking 2 light cuts for finished cuts. That's the best way to do it to maintain accuracy.